Hey and welcome back. Today in this section we are going to be starting off with our 2D platformer game development. So I'm going to go ahead and create a new scene. Go ahead and click create scene and I will call this scene platformer. And then I'm going to just simply double click it to open this scene. Okay, now I'm going to go to my assets and create a new folder called sprites. And in this folder I'm going to place my player sprites. So we have a package for you guys ready. You can see it has the Unity icon and it's type Unity package file. But Udemy doesn't allow us to upload Unity package files. So what we have to do is create a folder and under view, go to file name extensions and make sure that this is enabled. So what we're going to do is we're going to rename this and we're going to rename it as a PNG. And yes, save this. So now Udemy will think that this is a PNG file, but it really isn't. And when you download this PNG file, make sure to rename the PNG to Unity package. And when you change it, now if you drop it into your game, you can see now we have these sprites in this package. So we have a falling PNG. You can see this is a sprite sheet of the character falling sprites. Then we have shooting and idle, and then we have running. Let's go ahead and import these sprites. Hold on, Unity is importing these sprites. So this Unity package contains 4 of these images, which are all sprite sheets. So if I now select one, you can see that this is a image, and what we already set the sprite mode to be multiple, and we sliced these images for you. So if you go click on the sprite editor, you can see that they're all separate images. So this is called a sprite sheet. Just apply this. Let me just quit. You can see if I drop this down, we get all of these sprites separate, and it's the same for each one of these. Okay, we have the running animation, idle, jumping, and shooting. So this is going to be our character. Looks like Cuphead. If you haven't seen the game Cuphead, be sure to check it out. So that inspired us to create such a character for you guys. You can use this in your games. So I can go ahead and let's actually get one of these sprites and I can drop it into the scene. And you can see it looks really nice. First thing off the bat, I'm going to go to main camera. We don't want a skybox in our 2D game. So I'm going to set solid color and get something that will complement the character, something black like that. And I'm also going to downgrade the scale to maybe 0.5. Okay, this is also too big. Let's say this is too small, maybe 0.4. Okay, this is about right. And I will call this character. So this is going to be our player character, and we're going to add many components to him, including our player character script, which will actually move him around. Also, I've noticed our aspect ratio is 5:4 from our calculator. Let's change that to 16:9, which is the standard aspect ratio for PC games, for computers. And right now we only have our character. I'm going to add a component called rigid body 2D. This basically makes sure that this character will react to the physics in the world. So we'll be able to add forces to him. Gravity is going to be a factor. So if I run now, he's going to fall down, and I can see in the scene view he's falling down. Okay, so next time, now that importing and everything is ready, next time we'll create a script and we will make sure that we move this guy around and animate them. So thank you for watching. I'll see you in the next lecture. Hello and welcome back. So today we'll be adding a script to this guy so he can walk left and right. So I went ahead and made a new script called player character 2D, and now I'm just going to open it, and here it is, a blank script. So to move the character around, we're going to need some kind of speed variable. So let's go ahead and say public int speed, and let's make this public int speed. And now if I add this component to our character, let me just drop down the rigid body 2D. if I add this component, we have the speed parameter now, and we can increase and decrease it. Let's set it to 5 for now. So this is a side scroller, so we can move left and right. So let's go ahead and make a method called void movement. And I'm just going to look for key presses in here. So we can say if input.getKey and let's say key code D. So let's say if we're holding down D, what I want to do is to move the character around, we can simply take its transform and add some kind of value to it. So you can see transform position, we have X, Y, and Z. So in theory, if I take the transform position X and add something to it, here's going to be moving like that. So that's exactly what we want. So back in Unity, I will say transform dot position equals, transform dot translate. We want to translate its position, so we want to add some kind of values to it. To be more precise, we want to add new values to X, Y, and Z. So we have to create a new vector here, new vector tree, because it takes three values, X, Y, and Z. So since we're moving on the X-axis, we're going to say speed. So we're going to be adding our speed to the character, which is now set to 5, and let's just multiply that by time.delta time, just so it looks smoother. And we're going to be adding 0 on the Y and 0 on the Z, because we're only moving on the X-axis. And we have a error here. Oh, sorry, we don't say equals, we just say like this. Okay, so now we have transform translate and brackets, just a new vector tree. Then we say speed times time delta time. Now if I save this and back into Unity, now if I run, oops, our character is falling. Let me just disable the gravity here. And I forgot to call the movement method. Let's go ahead and in update, so each frame we want to check for movement inputs. So let's go ahead and in void update call the movement method. Now if I save and go back into Unity, if I run and if I press D, you can see our character is walking to the right. But we can't walk to the left. This is really easily fixed. Let's just go back to our script and then here say else if input.getKey, key code is this time A. So if he's holding down the A key, I want to say transform.translate new vector tree. And now, since we multiplied speed by times.delta times to move to the right, and the left is the negative of the x-axis, we just simply have to say in here negative speed times time.delta time, 0 on the y and 0 on the z. Now if we save this and back into our Unity, clear the console. Now if I click start, I can move to the left and I can move to the right. But there's one problem. If I'm going to the left, my sprite never changes direction. So if I'm holding down D, it's still facing the left, which looks really awkward. We can easily fix this. If you take a look now at the sprite renderer, we have this flip X and flip Y. So if I click flip X, there we go, our character is flipped. But flip Y, we don't really need that. So we need some kind of way to access this flip X through our script. Don't worry, that's really simple. You should know by now how to do this, but if you don't worry. Let's go ahead and get a reference to the sprite renderer. So let's say public sprite renderer. I will call it SR. And in here, we can just say when we walk to the right, we can say sr.flipx is equal to true. And when we're going to the left, sr flipx is equal to false. So each time we press D, we're going to go ahead and enable this flip X, so to flip the sprite. And now our script is looking for the sprite renderer, and just drag this down. There we go. So now if I run the game, I go to the right, my character faces the right, go to the left, and he faces the left. This is really convenient because if you look at our sprites, every one of them is facing to the left. But later when we set up our animator, each time we turn to the right, all of these will also be turning to the right. So you don't need to draw your character in both directions. One of them is enough. So that'll be it for this lecture. We got him to move around. So in the next one, we'll set up our animator. So we have some nice looking animations for him walking around. So thank you for watching, and I'll see you in the next lecture. Hello and welcome back. So today we're going to be animating our character. Creating animations in Unity is really simple and fun. We have a built-in animator tool. So let's go ahead and click on Window and go ahead and find animation, or you can just press Ctrl+6, and here we have our animation window. I'm just going to plug it in next to the console. Now if we you can see currently it says no animatable object selected. That's because we haven't selected any object that we can animate. But now if we select our main camera or any of these objects, we can in fact create animations for these objects. So with our character selected, go ahead and click create to create an animation clip, and I'm just going to go to my assets folder and create a new folder called animation, so we can have a nice, so everything is nice and organized. And I'll call this animation, let's call it 2D, just walk anim. Okay, and now we can see we have this preview here, kind of a timeline, and in here we're going to be adding our animations. So let's go ahead and get all of these. Let's select all of these running sprites and drag them inside of this. Now they're all close, and if you can see if I actually play this clip, you can see our character is running. But right now he's running really fast, and we don't want that. We can actually just decrease the size of these samples, let's say to 30. And we already have a nice looking animation of him running. Now I can just disable the keyframe recording mode. If you leave this enabled and change anything, it's going to think that you're creating an animation. So make sure to disable this. Now our character has a animator, and each object that has animations has a animator that controls these animations. So if I now open this animator, you can see currently we have, you can hold down Alt and left click to drag around and move in this animator window. Currently, when we start the game, we will go ahead and play the walk animation, and we'll just constantly loop it. That's because we don't have any other animation states to play. But you'll see later on, we're going to have much more animations and animation states, and things will be controlled, and you will understand why the animator is important. Currently, now the player animator will just say, hey, the game started, just play the walking animation, which is going to happen if I start the game. You can see my character is running to the left, and now he's running to the right. And I feel like our running speed is pretty slow, so let's go ahead and bump that up to maybe 10. Now if I start the game, now this feels much better. He's running much faster, and it's kind of a believable running animation. But you can see even if I stop running, he just continues running in place. That's because we only have one animation state. So let's go ahead and create a new animation for our character. With him selected, go ahead and you can see here we have the walking animation. That means that we're currently on that animation and that we're editing that animation. Well, makes sense. Let's click that and go ahead and create a new clip. I'm going to call this one idle anim. And let's go ahead and into our sprites folder, go ahead and get our idle animation. And let's just put all of them in here. Whoops. If we run, you can see it's too fast, but if I decrease the sample speed, let's see, Now it looks really interesting. So let's just disable the animation enter mode. And now in our animator, you can see that we now have the idle animation as well. And I'm just going to make a transition from entry to idle animation and make sure to delete this transition. Turns out I can't. No problem. Doesn't matter really. So now we want to create transitions from this animation, from the walking animation to the idle animation. So let's go ahead and right click and make a transition from walking to idle, and we also want to transition from idle to walking. So basically, if I'm not holding any buttons, I want the idle animation to be played, but if I'm pressing a button, I want the walking animation to be played. So we can do that really easily, don't worry. You can see here in the animator we have these parameters, and I can click on this plus icon here and add a float, int, bool, or a trigger. And I think a boolean is going to be really useful in this case. So I'm going to create a new bool called isWalking, and by default it's going to be false. And now I'm going to click on these arrow keys, and here we have the transitions for the animations. So the first thing is has exit time. Now this is useful for 3D animations. Basically what it does is when it needs to transition to a different animation, it's still going to play the current one for a short while and then continue with the next one. We don't want that. In 2D games with sprites that looks really weird. So go ahead and set has exit time to be false and disable all of these, set the values to 0. And now in here you will have conditions. So let's go ahead and click plus. And by default it's just going to select the only one that we have, so is walking, the boolean. And now we want to say change from true to false. So basically if is walking is false, it's going to transition from walking animation to idle animation. Now even though this walking animation is played from the entry, so when we start the game, now if I were to start the game it will play the idle animation, because by default is walking is false. I'm going to demonstrate that to you. So if I play, you see it's kind of bugged in. That's because we didn't create the transition for the from idle to walking. Let's go ahead and has exit time, disable has exit times, and set the condition is walking through. So back in our game, now if I run, you can see our character is doing the idle animation, and even if I walk around, he's still doing the idle animation. But if I were to go to the animator and click is walking is true, now you can see it's playing the walking animation, and he is in fact playing the walking animation. Now we need to figure out a way to access this boolean through our script. Don't worry, that's also really easy. And let's go ahead and do just that. So back in our script, the thing that controls these animations is the animator. So we need to create a reference to the animator. Let's go ahead and say public animator, call it anim maybe, yeah, sure, why not, and go to our character. Now you can see his script is looking for an animator. Just simply take his animator and plug it in. Okay, now how can we figure out when we're moving and when we aren't? Well, that's really simple. We have our if statements here. Basically, whenever we're pressing any of these buttons, what I'm going to do is, well, if we press D or A, we're obviously moving, so we want to change this value from false to true. So let's go ahead and say anim and dot set bool. This means set boolean. So we're setting the boolean and we're setting this boolean. So now we have to say the name, so it's is walking, and now the value that we're setting, which is true. Let's do the same for the when we moving to the left. Anim set boolean is walking to true. Okay, and now really easy, we can say else. So else, if he isn't pressing D or A, just simply go ahead and say anim set bool is walking false. Make sure that you spelled everything correctly. Now back in our engine, if I go ahead and run the game, my character is playing the idle animation. As soon as I start running, he starts running. You can see how the timing is perfect. The millisecond I let go of D, he starts the idle animation. And as soon as I click to walk, he starts the walk animation. There we go, our character is running in the world and he has the idle animation. Looks really great. So next time I think we'll go ahead and add some jumping and some platforms. So until then, I'll see you. Goodbye. Hello and welcome back. Last time we set up our animator and now I can move left and right, and I'm switching from idle to walking when required. So now in this lecture I want to create a jumping animation and some jumping logic. To be able to jump, we of course need some kind of platform to jump off of. So let's go ahead and back in our scene view, I can go ahead and create a 3D object and create a cube. Here's our cube. I'm just going to, let's name it ground. And if I press W, I can just move it down in the scene view and resize it. And now you might be thinking, well, our character is a sprite and this is a 3D game object. How can they collide? I mean, that's weird to wrap your head around. Well, actually, Unity makes this really simple. You can see that this ground has a box collider. Currently, this is a 3D box collider. So if I exit 2D game mode, and you can see if I edit colliders, you can see how it is a 3D box collider. Let's go back and disable this. Well, our player is going to have let's just add a box collider 2D. And you can see these just have a box collider on the X and Y axis. So this green rectangle is the collision area for this player. You can of course click edit colliders and resize it, but I think by default it looks great. Now if we go to rigid body 2D and re-enable our gravity, you might expect them to collide. Well, they won't collide just yet. That's because our player has a 2D box collider and the ground has a 3D box collider, and they can't really collide. So let's remove the 3D box collider from the ground and add a 2D box collider. And there we go. We can of course resize it if we so desire, but I think there's no need to do that. Now if I run the game, you can see our character falls and he stands on the ground and he can walk on the ground. And this looks really nice. We have this kind of feeling of depth here with the ground like this. And we're walking on it and things are great. Now let's go ahead and navigate to our script. And to jump, I'm going to give my player some kind of jump force variable. So let's go ahead and say public float jump force. And I will add force to his rigid body when he's about to jump. So in movement, before we get any of the walking input, I'm going to say if input dot get key down. So only when you press space, I want to jump. I don't want you to hold space and keep jumping. Key code space. I want to say, since we want to add force to our character, we need to reference the rigid body of our character. So let's create a public rigid body 2D. Let's call it rig. And back in our inspector tab, in the player character component, just drag our rigid body 2D component into the rig parameter. Now when I press space, what I want to do is say rig as a rigid body and simply add force. And the force I'm adding is going to be vector 2 since it's 2D, and I want to add in the direction I want to add force to is up. I'm going to add the jump force and again times time dot delta time. Okay, now save this and now back into Unity. When working with force, I think we need a greater value, so let's say 100. Let's say space now. I can walk around, so if I click space, nothing happens. Space. Vector 2 up, jump force. Let me remove time to delta time. You see he jumps really slightly. So let's go ahead and increase this value, let's say 500. I mean, the jump force of your character really depends on your game. Okay, so now we can see he jumps. I think 500 is also too much, let's say 400. You just need to fine-tune this to look and feel good for your game. I'm just showing you how you can do it. And there's a problem with how this is set up. Well, now if I can keep pressing space and I'm just adding force to this guy. And we don't want that. So let's go ahead and let's add a boolean is grounded. This will basically help us check if he is on the ground. So when the game starts, let's say is grounded is true. And when we want to jump, I'm going to say if is grounded is false. Actually, if it is true, only if he is grounded, I want to jump. If it's false, don't do anything. And then we need brackets here, and let's put this code inside of here. And as soon as we jump, we want to say is grounded is false. So he isn't grounded anymore, he's now in the air. Okay. So now if I press space, if I run the game, I can walk around, I can jump, and I can't jump anymore. And even when I'm on the ground, I can't jump. That's because we never reset the is grounded variable. We need to create some kind of check to see when we hit the ground to say is grounded is true. So let's create a new method here. I'm going to say void on collider enter 2D collision, and let's say call here. So this method is called each time we hit another collider, and this here call is the game object that we're colliding with, and it holds a lot of information. So we can say if collision.gameObject.tag is equal to, let's say, ground, we're going to say is grounded to be true. So now when we collide with something, we're going to check if the collision, if the object that we're colliding with, if its tag is ground. If it is, we're going to say that is grounded is true. So let's save this and back into Unity. And now we need to select our ground. And you can notice here we have tags, and currently this is untagged. And if we click this, we have respawn, finish, editor only, main camera, player, game controller. These are some of the built-in Unity tags, but we can simply in here say add tag and click on this plus icon and just say ground. Save this. Now back in our ground, make sure to tag it as ground, and let's tag our character as player. Tags are really useful for game development. You will see as we progress. So now when I hit the ground, I can jump. When I hit the ground again, I can't jump. That is because, let's see, did I ground? Yes, I think. Collision 2D here, I'm sorry. Minor mistake. So let's now run the game. I can jump, I fall to the ground, and again I can't jump, and that's because on collider enter 2D. Let's see if this will work. Okay, let's clear the console, run the game. I'm getting an error, so it says, okay, it's collision 2D here. Now again, if I run. Okay, now we can jump. Sorry, I get these on collision methods confused. They're really similar. We have on collision enter and on trigger enter and on collider enter. They're really similar. But now we got it working. So basically, when I jump, I can't jump anymore. So the script knows that we're not touching ground, so we're in the air. And then when I hit the ground, which is tagged as ground, it knows, hey, he's grounded, so he can jump again. That's basically what this here does. So later we can have checks for checking if we collided with a game object which tags enemy or checkpoint or level switch. You get the idea. And then each time we actually do collide with a game object called enemy or something, we, for instance, can take damage or increase our score, whatever. So this lecture is getting pretty long. Next time we will set up the animator to work with our new logic. I thank you for watching, and I'll see you in the next lecture. Hello and welcome back. So last time we made some animations, a movement script and jumping. But you can see now if I jump, he will just play the previous animation state. That means that's because we haven't set up our animations for falling. In our animator, we only have the idle and jump animation. The idle and walk, sorry. So when we jump, he's just going to be playing either the idle or the walking animation. And also the jump feels kind of boring. We'll also be fixing that. But first, let's go ahead and set up our animations for our guy. In our sprites folder, we have the fall sprite, which has 6 images, which we'll be using for our falling. So let's open up our animation window. If you don't have this here, just go ahead and click on window and go to animation, or you can press Ctrl +6. I have it here conveniently. And you can see that currently it's selected the walking animation, and if we click on this drop down, we have walking or idle. But I'm going to click create new clip, sorry. And I'm going to move to the animations folder and call this animation falling.anim. If you couldn't do this, that's because you need to select the character so Unity knows what we want to animate. Let's go ahead, and I'm going now to select all of these sprites here from our sprites folder and just drag them into my animations window. Now if I play this, you will see that he's falling at a pretty fast speed. So I'm just going to stop that and change the sample speed to maybe 20. And now if I play, I have a much better falling animation speed. Now I'm going to disable the recording here, and let's move to our animator. And by default, you can see we instantly have the falling animation here added for us. If I hold down Alt, I can move around in the animator. And now we want to create transitions from walking and idle to falling. So basically, we can jump when we're walking and when we're idling. So let's go ahead and create transitions from idle and walking. And we also need to transitions from falling to idle and from falling to walking. Now I'm just going to select all of these arrows and make sure that the exit time is disabled. We spoke about this. Exit time looks really bad in 2D games, but you will see later when we start developing a 3D game that exit time is going to be really useful. Okay, now I've disabled the exit time on all of these transitions, and I'm going to go ahead and transition from idle to falling first. So we need to think about, when do we want to transition from idle to falling? Well, basically, if we jump, so I have gone ahead and added this isGrounded boolean parameter here, but you can just, I will delete it now. So under parameters, click on plus, and we can add a new boolean. And let's just call it isGrounded. And if you remember, in our script, we also have a variable called isGrounded, which just checks if the player is on the ground, and if he is, it enables him to walk around and things like that. And now we will be using this boolean to know if we should be playing the falling animation. So basically, if we are on the ground, that means that we shouldn't be playing the falling animation, but if we aren't on the ground, we're probably flying, falling, jumping, so we should be playing this animation. So let's click on this connector here, and let's scroll down under conditions. The list is currently empty. I'm going to press this plus sign, and I'm just going to set isGrounded to false. So when isGrounded is false and we're idling, we'll be playing the falling animation. And now from falling to idle, we want to transition when isGrounded is true, and also when isWalking is false. So when we're not walking and we are grounded, we're probably idling. Next up is from walking to falling. We want to do this when, again, is grounded is false. And from falling to walking, we want to transition when is grounded is true. And we can say is walking is true as well. Okay, so if I now drag this animator down here and run our game, you can see we're playing the falling animation because by default is grounded is set to false. But if I set it to true, he starts idling. Now if I was to enable walking, I can't enable walking for some reason. That's weird. Never mind, let's continue. Let us go to our, oops, not the assist store, to our script here. And a very easy way to check this. Well, first off, let's go down and you can see on collision enter 2D, basically when we hit a game object that is tagged as ground, we just set is grounded to be true. Let's just go ahead and say that anim set boolean is grounded is also true. And in the update method we can simply say if is grounded, then we can say anim dot set boolean is grounded true, else. Basically each frame we can check if the character is grounded, and if it is, we will be sure to change the values of our is grounded boolean in the animator. So if the character is grounded, we will set the boolean, the parameter in the animator to be true as well, but if he isn't, we'll set it to false. And now if I save this, I can go back into my Unity and I can hit play. You can see I'm now running around. If I jump, I am jumping. And you see how we perfectly play the falling animation whenever we are in the air, so whenever we are not grounded. There's a problem with our jump. So if you notice that, you probably did notice if you're running the game, but if you're watching and not working along, you might have not noticed it. Basically, when I jump, let's say it takes me 1 second to get to the maximum point, and then it will take me 1 second to get to the bottom, which is accurate in physics terms, but in the world of games, that isn't really fun. It doesn't feel good. If you remember Mario, you can jump high, but then he falls down really quickly, and that feels really good. It feels like your character has a lot of weight. So let's go ahead and improve that jump. Go back into our script, and basically what I want to do is check if my rigid body dot velocity dot y is, let's say, less than 0, and if it is, I can say rigid body velocity dot y plus equals, actually just rigid body dot velocity plus equals, and let's say vector2 dot up, since that's the y-axis, we're jumping, we're going up. We can actually multiply this by physics 2D dot gravity dot y, and let's multiply that by maybe 2, and time dot delta time. We spoke about this. This is really important when doing any physics related things in the update method. So each frame, if our velocity is less than 0 on the y, we're going to be adding to our velocity on the vector up the gravity on the y times 2 and times dot delta time. So let's save this and see how this feels. Okay, now I'm running around, I jump, and you can see I fall down much faster. This feels a lot better. Even if you're just watching, to you it must feel also better. No, it's really noticeable, and that's a really easy way to make your jump feel much better. These things are polish, and they're called sometimes game juice or game feel, and it's what really makes some games amazing. For example, camera shake in Nuclear Throne, or the jump in Mario or Super Meat Boy. Without those things, those games wouldn't be that popular. So as an indie developer, you really need to pay attention to those small details and make sure that your game just feels amazing to play. And when your game feels amazing to play, you won't need an amazing AAA art style or graphics to sell a ton of copies. Okay, so that's been my time for this lecture. We'll continue in the next one. Until then, goodbye. Hello and welcome back. So last time we made the falling animation and we also improved our jump. Now it feels much better and the game is getting pretty fun. So today what I want to do, in our sprites we have the shooting sprite that is left to be implemented. So we're going to implement shooting. We have these 4 sprites here and we'll make him shoot when we press the left mouse button. And then we're going to add some kind of bullets so we can actually shoot some bullets. So let's go ahead and jump right in. If you don't have the animation window open, you can just simply go to window and click animation or press Ctrl+6. You can see now in my animation window it just says no animatable object selected. That's because I haven't selected my player. So I'm going to go ahead and click on character and now you can see we have his animations here, and by default the walking animation is opened. So I'm just going to click on this drop down window here and go down to create new clip, and I will move to my animations folder because I like things to be in their respective folders, and call this one shooting. Now let's select all of our shooting sprites and add them into the animation window. Of course this is too fast of an animation, so I'm going to decrease the sample speed to maybe 20 and now play. This is also pretty quick, so let's say 15. Let's get the first sprite and place it back again, so we kind of have a transition from the last position to the first position. Okay, I'm done with that animation, so let's open up the animator, and you can see by default we already have our shooting animation added to this animator. The way this game is set up and the way we have our sprites, I only want to be able to shoot when I'm walking or idling, because our falling animation looks like this, and it would look really bad if he was falling and then stopped to stand like this and then shoot. So I'm just going to enable him to be able to shoot when he's either walking or idling. So let's go ahead and create a transition from walking, and then from shooting to walking, and from idle to shooting, and from shooting to idle. Don't forget to select all of these transitions and disable the exit times for them. That is what I'm doing now. Okay, we're done, and now we need some kind of condition that when is met we're going to be playing the shooting animation. So I'm going to, under parameters, click on this plus sign and add a new boolean. I will call it is shooting, and then I will just say from walking animation to shooting I will transition when is shooting is true. From shooting to walking I will transition when is shooting is false and is walking is true. From idle to shooting I will transition when is shooting is true, and from shooting to idle I will transition when is shooting is false and is walking is also false. Okay, now we have this set up. So we're going to save this and go back to my Unity. Okay, go back to Unity and let's open up our script. And in our movement method, where we jump and walk around, we can add our shooting. So let's say if input.getKey, okay, actually get mouse button down. This refers to a mouse button press. So let's now open a brackets, and here we have a integer button which is looking for a value. So I'm going to say 0, which refers to the left mouse button. 1 is the right mouse button, I believe. And now I'm going to open curly brackets, and in here we can say anim. Let's set boolean, and we can set is shooting to be true. Now if I run our game and left click, he will just be stuck in the shooting animation. You can see he's just shooting, and even if I walk around, jump, he's going to be shooting. So we need some kind of way to stop the shooting animation. This can be done really easily. Basically, I'm going to reset this whenever we do anything else. So let's say when we move, right, I'm going to set this to false. So any movement will cancel the animation. Okay. And also the jump will also cancel the animation. But this still hasn't fixed our problem. I mean, now I can shoot and then continue walking or jumping, but if I just left click and don't do anything, he's still going to be stuck in this animation. So a thing we can do is go to the animator and click on the shooting animation and have the transition from shooting to idle. We can say has exit time, and we can just remove these conditions. So basically we're going to go from shooting to idle whenever the animation is done. So let me remove the conditions. And let's just finish the shooting animation and then instantly play the idle animation. Okay, let's go ahead and try that. So that doesn't look good because its shooting is still true. Yeah, we need to reset it through our script. A really easy way to reset it, we can just create a new float, call it maybe shoot timer, and set it to maybe 0.2 f. And whenever we shoot, we can, let's create a new boolean called shot timer, and we're going to say if shot timer is false, we will be able to shoot. Let's just let's do it like that. If shot timer is false, then we're going to shoot, and we're going to set it to true. Okay. And in the update method, let's first, when the game starts, I'm going to set shot timer to be false. And in the movement method, I can say shot timer minus equal, actually shoot timer minus equal time.delta time. So each frame we will be deducting the shoot timer, but only if the shot timer is true. And if the shoot timer is less than or equal to 0, what we're going to do is set the shot timer to be false. So we will be able to shoot again. And then we're going to set the shooting animation to be false. And let's also reset the shoot timer. And there we go. Let's open up Unity and run. So now we can see I shoot and we go back to the idle animation. And it works perfectly. So that's going to be it for this lecture. We're going to, in the next one, implement shooting bullets. Thanks for watching, and I'll see you in the next one. Hello and welcome back. So last time we made our shooting animation, and now in this lecture we're going to actually be shooting something. So let's go ahead and create the actual bullet that we will be going to shoot. It's going to be a game object, much like the player is a game object. Now I don't have any sprites for the bullet. This course is going to focus on 3D development, 3D game development, but I just want to show you some basics of 2D game development. So sorry for not providing you with more 2D sprites, but let's just go ahead and work with what we got. So let's go and create a new 2D object, a new sprite. I'm going to call this one bullet, and I'm going to, in the sprite renderer, under the sprite component, click on this icon, and I'm going to choose a sprite. Let's not take our character sprite, let's go with this knob. And I'm just going to increase this to maybe 3. That's maybe too much, let's say 2. Okay. And this is going to be our bullet. We of course need to add a circle collider. Let's just decrease the radius a bit. Okay, that's better. And let's add a rigid body to this object. A rigid body 2D. I'm just going to disable the gravity for this object. Okay. So now that we've got our bullet ready, I'm going to create a new folder in our assets browser, and I will call it prefabs. And in here I will simply select my bullet and drag it down here. And now we've made a prefab of our bullet. So you can see that this object has everything that our bullet had, and we can just simply drag it in our scene, and we always get a copy of this object. And now if I were to change something to this prefab, the object in the game, all of the objects would also change. So that's pretty nifty, I would say. Okay, so now that we have the bullet ready, I'm just going to delete it from the scene, and we will be actually spawning it from our player script. When we click left mouse button, I will be creating a bullet that's going to be flying to either the left or the right direction. So let's go ahead now on our character. Let's create another 2D object, a sprite, and I'm just going to get a placeholder sprite, maybe, okay, this one. I'm just going to reset its position. Whoops. Okay, and I'm going to now move it, and I will position it somewhere where his fingers are. So this is where I actually want the bullet to spawn, and I will call this object shooting position left. I'm just now duplicate it and call this one shooting position right, and I'm going to move it to the right, and now we have these 2 points from which we will be spawning bullets. Let's select both of these and drag them under our character, so now they're the children of our character. And now if I run around, you can see these 2 objects follow our player. So if I were to click left click, I would shoot out a bullet from that position. Okay, now I'm just going to remove the sprite renderer so we don't actually see those. We don't see these positions, we want them to be hidden. And let's go back, open our player character script, and get a reference to these positions. So let's say public, and these positions are transforms. So public transform position left and public transform position right. Let's also get a reference to the bullet. So public game object bullet. Let's save the script and now go back into Unity. And you should see our player character component update with the position left, position right, and the bullet. So let's go ahead and from the prefab folder grab our bullet and simply drag and drop it into the inspector. And now take our shooting position left from the hierarchy and put it in the inspector, and put our position right in the inspector as well. Now let's go back to our script and move down to our movement method, where we actually shoot. When we play the animation, we want to create a bullet. Let's go ahead and just say instantiate. Actually, first we need to figure out in which direction we're facing. We can check that simply by seeing if the sprite is flipped or not. So if it isn't flipped, that means we're facing left, and if it is flipped, that means we're facing the right. So let's say if sr.flipx is false, that means we're facing the left. I want to say instantiate, and now this method takes in 3 parameters. First, it takes in the object that we're creating, which in our case is bullet. Then it takes the position at which we will create it. So let's say transform.position. Actually, sorry, we want the position left. So let's say position left dot position. And finally, we get a rotation. We can just say transform dot rotation. And now we can say else if the sprite is, if our player is flipped, we're just going to instantiate it on position right. Okay, now if I save this and go back into Unity, we're still not done. You will see we have some problems. If I now play the game and press left click, we just create the bullet. We do create them on the right positions, but they don't fly off into the distance. Don't worry, we'll fix that right now. Let me just play around with these bullets a bit. Okay. So basically, we need to give them some kind of velocity. So let's go ahead and here get our curly brackets and cut this first instantiate and paste them inside of the curly brackets. And now we want to say game object new bullet equals. So basically now we create a variable of type game object, and we put its contents are going to be the bullet that is created right now. So now with this new bullet variable, we can access everything that this bullet has, so circle collider, rigid body, and etc. And we can use that to move this guy around. So we can get his rigid body 2D and add some kind of velocity to this bullet. And that's exactly what we're going to do. Let's get a new line here and say new bullet, oops, new bullet dot velocity, oops, dot velocity, rigid body 2D. And we have to get the component. So let's say new bullet dot get component. So we have to get the rigid body 2D component. And now that we have the component, we can just say velocity equals vector2 dot right. We are moving on the x-axis, so that's vector2 dot right, but we're moving to the left, so we're going to multiply this by a negative of, let's say, some shot speed value. Let's just now create our shot speed, public float shot speed. Okay. And now we have to say else and get the curly brackets going. And inside of here, again, let me just cut this and paste it up here. We want to say game object new bullet equals the created bullet. And then after that, we will say new bullet dot get component, the rigid body 2D component. And we want to say velocity equals vector2 dot right times shot speed. Okay, let's save this and go back into Unity. And now our player should also have a shot speed. Here, let's just place in a value of maybe 5 and now play the game and see if everything works. If I shoot, you can see the bullet is being shot out, but it's really slow. So let's say shot speed maybe 15. Okay, this is better. But we have a problem here. If I can keep creating these bullets, and you can see how my hierarchy is getting filled up with these bullet clones, and they're actually all traveling. They still exist, and they're all still traveling in the scene. If I can somehow show you, you can see how these guys are going off to their own path. And if your game is long and you have a lot of shooting, this can be a problem. These game objects are all using CPU resources to calculate their position, their velocity, and all those things. So we don't want that. We want some kind of way to remove these bullets after a set time. So we'll do that next time. That's a really simple fix. Don't worry, nothing too complicated. Thank you for watching, and I'll see you in the next lecture. Hello and welcome back. So last time we implemented shooting these bullets, but we have a problem now, which is we can continue shooting bullets and they just spawn and never leave the scene. Don't worry, we're going to fix that. It's a really easy fix. Let's just go ahead and open up our scripts folder, create a new script. I will call this one destroy timer. Destroy timer, yes. Okay. And I will open it up. Now, this is going to be a really easy script. I'm going to delete the start method, and I'm just going to create a public float called timer. And in the update method, I will say timer minus equal time.delta time. And if timer is less than or equal to 0, I want to destroy game object. So this will destroy a game object as soon as the timer is less than or equal to 0. So basically we can now take the script and put it on any object that we want. So for example, our bullet prefab. Let's go ahead and get our destroy timer script, and now in here we have a timer variable, and I can set this to maybe 1. And now if I play the game, after 1 second this bullet will be destroyed. As you just saw there, it appeared and then disappeared. So I can just keep shooting these bullets and they'll keep disappearing, and my game won't have too many unnecessary game objects in the scene. Also, what I want to do is when these bullets get destroyed, I want them to play a particle. So I'm going to create a particle. Let's go ahead and go to create particle system. Now we have a whole course on particle creation where we go in depth into explaining how to create cool particle effects. So I won't go into too many details here what these are. Instead, I'm just going to create a particle effect really quickly. Go to emission. I will change this to be 0. I don't want particles over time. I want a burst of particles, and I will set the minimum number of particles to be 10 and the maximum to be maybe 100. And then I will move down to shape and change the shape from score to sphere, from cone to sphere, sorry. I will set randomized direction to be 1. And then I will go to the simulation speed and set that to maybe 3. And then I will go to the start size and set that to 0.1. Now I will call this particle system bullet explosion, and also be sure to drag it down into the prefabs folder. Okay, let's delete this one now. So let's open up our bullet and go open the destroy timer script. And right here, before we destroy the game object, let me just get my curly brackets. Before we destroy this game object, I want to instantiate the particle. So I will get a reference public game object particle, and then I will instantiate my particle at transform.position with transform.rotation. Okay, let's save this and let's go back into Unity. Now there we go, our component updated, and let's just plug the particle in here. Now if I run the game, you can see after the bullet disappears, we play the particle, but we have a few problems here. First of all, the particle is looping, and second of all, we have more of these particles here. It's the same problem as we had with the bullet earlier. So let's go ahead, since we made the prefab of the particle, just select it and be sure to disable looping. And let me just check something here. Okay, now it shouldn't be looping. So it should just play once, but we still have the game object here. What we can do is simply attach our script to this particle effect. Let me just find it and go ahead and add component destroy timer and just set this to maybe 5. And now you see, now it also wants a particle effect, but this wouldn't really make sense to create a particle from the bullet and then when we destroy the particle to create another particle. Let's just leave this blank and say if particle. There we go. So basically what this does is, if this variable is filled up with something, we're going to instantiate that thing. If it isn't, we're just going to destroy the game object. So now we can plug this script into any game object and if it doesn't have a particle, it doesn't matter, it will still work. Now I'm just testing it, and there you see it's been alive for 5 seconds and then disappeared. Let me just get the camera, bump up the field of view so you can see more of this. So things are going to explode quickly, and now you can see our hierarchy has these explosions and they're slowly disappearing. So you can see how we made this script really, it can be used on many different game objects that you want to destroy over lifetime. So even it requires a particle game object, but even if we don't plug it in, it's going to work perfectly, because we said only if it has the particle attached, instantiate that particle. If it doesn't, just destroy the game object. But if it does have the particle, instantiate the particle and destroy the game object. Another quick thing I want to show you is, maybe, let me just get the field of view so we see more. Maybe you want the camera to follow the player. A really quick way to do that, you can just set the camera to be a child of the player and just maybe move it up a bit. Now it will follow his movements, but you can also create a script that follows the player. By now you should know how to do that, and I hope you will do that. That's a task from me to you, and that will wrap up this section. In the next one we will be creating a Space Invaders game with 3D models. So we're going to have a lot of special effects, sound effects and music for you guys to download and use in your own games. So stay tuned for that. I thank you for watching, and I'll see you in the next section.